Hello everyone. In this video I'm going to draw more covalent structures. Let's get started. Okay, the first example we have here is CO2. We'll follow the same rules that we have discussed in the previous video. For that reason, if you didn't watch the previous video, you need to return to it to study the rules and the notes. Okay, so we have carbon 6, oxygen 8. This is the number of electrons or the atomic number. So we have here 2, 4, we have here 2, 6. How many valence electrons? We have 4 valence electrons. Here we have 6. How many needed electrons? We need 4, so it should make 4 bonds. Here it needs 2 electrons, so it would make 2 bonds. Okay, so we have carbon that will make 4 bonds, and we have 2 oxygens. Each oxygen would need 2 bonds, so we'll have here 2 and there 2. That's great. What about, so we have used all the valence electrons for carbon. What about oxygen? We have 6 valence electrons. We have only used 2 of them, so we have 2 lone pairs for each oxygen. This structure is same as CS2, so same idea, CS2, okay? Let's move to the next structure. We have NH3. We have nitrogen, which has 7 electrons. Hydrogen has 1, so it is 2, 5, here 1. Valence electrons 5, valence electrons 1. Needed electrons are 3, so 3 bonds. And here only 1 bond. So we have nitrogen, which should be surrounded by 5 electrons, 5 valence electrons, and it only make 3 bonds. So 1, 2, 3 bonds, which means that we have 1 lone pair. So we have here hydrogen, another hydrogen, and another hydrogen. So this is NH3. Never forget the lone pair. These structures same as PH3. So if I'm trying to draw PH3, here's PH3. Why they have the same structure? Because nitrogen and phosphorus are in the same group, So they have the same number of electrons in the last shell. Same as PF3 or PCl3. If I'm trying to draw PCl3, same idea. It would only make 3 bonds, Cl, Cl, Cl. And phosphorus has 1 lone pair. I don't have to forget that chlorine has also 3 lone pairs because it has 7 electrons in the last shell. Okay, what about BF3? B has 5 electrons, so it's 2, 3. F has 9 electrons, so it's 2, 7. You don't have to memorize the atomic number, it's given in the periodic table. So we have here how many valence electrons? 3. How many valence electrons? 1. So here it has 3. Boron here has is an exception here. So it would only make 3 bonds. It's an exception. Boron is an exception. What is the exception here? Boron would be satisfied by having only 6 electrons in the last shell. Okay, and fluorine would make only 1 bond. So we'll have B, and it has, as you can see here, we have F, and fluorine has 3 lone pairs because it has 7 electrons in the last shell. It would only make 1 bond, and it has 3 lone pairs. Boron has no lone pairs because boron has only 3 electrons in the last shell. Boron is an exception. It is satisfied by having 6 electrons. Same with BH3. We just draw the same structure, Lewis structure, but without lone pairs surrounding hydrogen because hydrogen has only 1 electron in the last shell. Okay, we have here 3 atoms. We have H, we have C, we have N. H is 1. C, we have C6, nitrogen 7. So we have here 2, 4, we have here 2, 5. Here we have 1 valence electron, 4 valence electrons, 5 valence electrons. 1 bond, here 4 bonds. Here we have 3 bonds. For some students, it might be confusing which one should be the central atom, the atom that would make the most bonds. Which one? Of course, carbon, because it can make 4 bonds. So I have to draw carbon first. It has to make 4 bonds. Hydrogen would make only 1 bond, so 1 with hydrogen, and 3 with nitrogen. I don't have to forget that nitrogen has 5 electrons in the last shell. So we have a lone pair. The most important thing is to check the valence electrons. How many valence electrons carbon has? 1, 2, 3, 4. Okay, this is good. Nitrogen, 1, 2, 3, 4, 5. Good. Hydrogen, only 1. Next step is to check if each atom is satisfied or not. Yes, hydrogen is satisfied. As you can see, it has 2. What about carbon? Let's check here. 1, 2, 3, 4, 5, 6, 7, 8. Happy. So what about nitrogen? 1, 2, 3, 4, 5, 6, 7, 8. Everyone is happy here. Let's move to the next example. We have carbon and chlorine. Carbon is 6. Chlorine is, of course, 17. So we have here 2, 4. We have 2, 8, 7. Okay, so how many valence electrons? 4 valence electrons, 7 valence electrons, 4 bonds. Here we have only 1 bond. So we have the central atom, of course, the atom that would make the most bonds. So we have carbon, and it would make 4 bonds with Cl, 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 and Cl. This is Lewis structure. I don't have to forget the lone pairs for the chlorine atom. This is very important. Same structure will be for CF4 or for CH4. We draw CH4 in the previous video. So next we have Be. Be is 4 is an exception. Also, as we'll see now, it is 2, 2. Okay, you would say that, okay, is it a metal? Yes, it is in group 2, but still making a covalent bond. So we have Cl, 17, so it's 2, 8, 7. So Be, beryllium, has 2 electrons, so it would make only, it has 2, 7. How many bonds? 2 bonds. And we have here only 1 bond. So beryllium would make 2 bonds with each chlorine atom to make this structure.